Hello, this is Minky for the course Probability and Stochastic Process. This is homework 9, exercise 7. For this question, it lets us to show that random telegraph signal is a strict and stationary process. So firstly, let me change the color here. The strict and stationary process is that ytn equals to yn to yt1 equals to y1 is equals to ytn plus epsilon sorry, there should be a time shift. It's like the probability of the original this probability with a time shift epsilon. The probability does not change. So this is the strict and stationary process characteristics. So we are gonna to prove this, and we know that the process is a random telegraph signal. So firstly, we could write this conditional probability, and since with the previously we proved that this conditional probability is equal to this, right? And then we could then prove this, write this and write it as a conditional probability with times together. And since they are all Markov process, and we could ignore the past terms, so that is why we could write here the first, this one, we ignore all the tn minus 2 to t1 equals to 1, so we only left tn minus 1 here because of the characteristic of Markov. So we could do this for every term. So for each conditional probability term, we only have one condition here. You could see that, right? And for the last term, we need to times a probability of yt1 equals to 1. So it times this times all this together is equals to the this united probability. And then since from the first step we know that this conditional probability is equals to this kind of, we have a formula here, and we take this formula to every term. So you could see that the final result is like this, and the last term's probability equals to 1 over 2. And it all depends on the ti minus ti minus 1, right? You could say tn minus tn minus 1, and here, yeah, they are the same. So we only care about the previous and current times the interval of these two time, right? So we only cares about ti minus 1. I is from 2 to n. So if we have a time shift for t, like for ti, time shift with epsilon and minus ti minus 1, there's still a time shift, and we minus them together is still equals to ti minus 1. So they are the same. Then we prove that the random telegraph signal is a strict and stationary process.